How about a Marlin config for a Core XY 3D printer? This is my Seckit SKGO. You can tell because I put the name on the front. I do really like this machine. It turns out a very nice quality 3D print, but there are a couple things that I'd like to change up. And I've been having some problems with the main board that came with the machine. It came with an SKR 1.3, but I can no longer connect up via serial, so I can't use Octoprint, and I do think it's something wrong with the board. So I thought this would be a great opportunity to make some changes to the printer and upgrade the main board to an SKR 1.4. Also, it is currently using TMC 2130 drivers, and they do run just a bit warm, so we might as well upgrade to some 2209s. And I do plan on adding auto bed leveling. But to make any of these changes, we have to change the Marlin firmware. So this is a great opportunity to walk through Marlin step by step and get a Core XY machine configured with all the features that we want to add. So let's get right into the code. As we have done many times before, we are going to head to marlinfw.org and head to downloads. I believe there have been some fixes released in Marlin since we did the last video, but we're just going to download the 2053 version right here. We will head to downloads and extract all. And let's just add SKGO to our folder name, and we'll hit extract. We have extracted. I'm going to go ahead and rename this internal folder as well, just so I can keep everything straight. Now, Ernest over at Seckit does have the firmware that you can use for this printer, and he does make updates. He has a GitHub. I will leave a link to it in the description below, and he has made some updates within the last couple of months to the firmware. So you can just go download this firmware and tweak it for the style of printer that you have and use that. It'd be just fine. But that's not near as much fun as creating one from scratch, and we don't learn near as much. So we will open up VScode. I will add my project folder. We'll expand Marlin, and we'll open up configuration.h. Now there really isn't a whole lot special about the Core XY configuration. There's just a couple of options that you need to set, and then the firmware will know how to handle that. Basically, you don't have an X and Y motor anymore. You have what I like to call an A and B motor. Those two motors work together to make all the X and Y movements. If you move left and right, both of those motors turn the same direction together. If you move forward and back, both the motors turn in the opposite directions. And then if you move in a 45-degree angle, only one motor is going to turn at a time. I do show this a little bit more later in the video. I don't have a video that's dedicated to the Core XY movement, but maybe that's something we want to go over at a later time. But I'm not going to get really in-depth in this video. Maybe that's something we'll touch on in the future, but for now, let's just get the configuration all set up. Let's update our author comments so we know what we're doing. I usually just put my name, the date, and the printer we're working on. For the SKR 1.4, I'm just going to change the main serial port to -1. -1 will use the USB emulated serial port that's on the SKR 32-bit boards. We'll leave it at a 250,000 baud rate, and we're going to change up our board name. You've seen me do this 100 times, but we'll go to Source, Core, Boards. The boards are listed by processor. We will go down to the 1769 because we're going to use the turbo board, and we'll grab board BigTreeTech SKR 1.4 Turbo. We'll copy that, back to configuration.h, and we'll paste in the board name right here. I am going to update my custom machine name. This is what's displayed on the screen when it's idle. And we'll just put SKGO. We only have one extruder. We will update the filament to 175 because that's the size we use. Not super important unless you're using specific features, but it is good practice to get into. We don't need to change up any of the power supply settings because I don't have any PSU control on this printer. Thermal settings, we will update our thermistor. This printer uses a 1, the standard 100K thermistor on the hot end, and on the bed. We can always go back and tune PID later and use those numbers for our configuration, but I do have the configuration.h file that Ernest uses when he builds these printers, so I can just use those values for now and go back and tweak them a little later. So I'll paste his values in here, and we'll just comment out these default Ultimaker values. For the bed temp, this is an AC bed. It heats up really quickly. PID probably isn't so necessary on the bed, so I'm just going to leave it bang bang. You can turn it on if you'd like to PID the bed, but you have to tune it as well. We will leave prevent cold extrusion. That's a nice safety measure. Prevent lengthy extrude. If you have a long Bowden tube, you might want to consider making this a little longer. This printer is set up with a direct drive knockoff Titan extruder for now, so I really don't need to adjust this, so we'll just leave it at 200. But if you need to make long loads or something like that, you're using a script to load and unload filament, you might want to consider increasing this. Thermal runaway, we will leave that intact. Safety is always good. And then in the mechanical section, this is where you're going to decide how your Core XY is set up. There's a couple of different ways to do a Core XY-like printer. You can see all the different mix-ups that you can use. We've just got a regular Core XY, but there's XZ, YZ, YX, ZX, ZY, all these different crazy configs that you can do. But for now, this is just a standard Core XY setup. For Core XY, all of our end stops are going to be using the minimum plugs, just like a standard i3 machine. All of the pull-ups and pull-downs can stay default, no change-up needed there. For all of the end stop settings, I'm going to leave inverting to false because we are going to use sensorless homing on the 2209 for X and Y, so those have to be false. And I'm going to use an inductive probe, and it's an NPN sensor, but I believe it is normally closed, so we're going to set that to false as well. That's the only one I'm not 100% sure about, but I think both of these need to be false. But we'll test that when we add the probe. On our drivers, we're just going to uncomment all 4 of our drivers, X, Y, Z, and E0, and we're going to change them to TMC 2209. We will be using them in UART mode. And then we come down to movement settings. We're going to have to change up a few things here. We will be using 16 times microstepping, and those are 16 tooth pulleys, so we'll want to change X to 100, Y to 100. We will set our Z steps to 400. These are 4-start lead screws, TR 8x8s, and they do have a belt connecting them, but it's a direct drive setup. So 400 is still valid. 1 Z motor, 2 screws. And again, I mentioned I have a knockoff Titan extruder setup. I've got my E-steps set to 402. These do have to be calibrated depending on what extruder you use, but 402 is working good for me. Now, a lot of times on the channel, we deal with Cartesian i3 style machines, log, the Prusa machines, the Ender 3s, and those configurations are pretty much similar when it comes to feed rates and accelerations. Core XY is going to be just a bit different. Depending on the Core XY setup you have, a lot of times you could be moving a whole carriage back and forth when you're moving, not just the X part that has the hot end on it. And in this case, we actually have a direct drive extruder on that carriage as well as moving that bar back and forth. So there are some considerations to make there. The more or less mass you have, the different settings you're going to have to tweak to get it to work properly. So for the SKGO, we are moving around just a little bit of mass there, but I am going to up the feed rates just a bit. Remember, these are maximums, so whatever your slicer sets, that's what you're actually printing at. These are the maximum allowable feed rate. So I'm going to make X and Y 500. It is important on a Core XY machine that these two be the same if you were to ever happen to hit that maximum. I'm going to change Z to 30 with a drop-down type of bed. This isn't super important, but it will let you home and move around a bit faster. And my extruder, I'm going to take from 25 to 100. This will allow you to do faster retractions if you'd like to set it that high. I usually don't, but again, it's a maximum. Then we come down to max acceleration. I'm going to slow these down just a bit from default. I'm going to do X and Y to 2000. Z can stay 100. And then I'm going to take E down to 2000. Most of the time on the extruder, you're moving in very small increments, so you don't have to ramp up or ramp down slowly for acceleration. But 10,000 is kind of a ridiculous number. It's not going to mean a whole lot on the extruder, but I'm more comfortable with it at 2000. Remember, acceleration, if you're going from 0 to 100, this is how fast it will ramp up to get you there. And these are default accelerations right here for the whole machine. Not necessarily when you're printing, retracting, or traveling. Those acceleration values are down here. This is default acceleration while extruding for print moves. And that one, I'm going to make it max 1000. I want it to accelerate just a little bit slower while it's printing to get that mass up to speed so we don't cause issues. Then E acceleration while you're doing your retracts, I'm going to limit that to 1500. And same for travel acceleration. 1500. Non-printing moves. So when you're moving from different mechanic systems, one to the other, you're going to have to take these into consideration, as well as things like jerk and junction deviation, which we're going to set next. By default, nowadays, Marlin does use junction deviation, and we will use that for this config. So we'll skip over classic jerk for now, and go down to junction deviation. This is something that really should be tuned by looking at the print. If you head to this site right here, they do a pretty good job of explaining how junction deviation works. They even give you a calculation that you can convert your existing jerk values, if you have those dialed in, to a junction deviation value. At this point, the default setting, the 013 setting, is fine by me. We can tune that later if we're seeing issues. I am going to be using an inductive probe, so I am going to use my Z minimum probe, uses Z minimum end stop pins. I'm just going to plug that probe into those pins and it'll power it up, and I can trigger the end stop with it. You can use whichever probe you wish. You can change that up in the pins file. And in this configuration, I won't need my end stop switch to home the printer. I'll just use the probe. We are going to be using an inductive probe. It's going to be fixed mounted. So I'll uncomment this line. And then we have to set our nozzle to probe offset. That's where your probe is located versus where the nozzle is located. You can see the map up here. If you're in the back, it's a positive. If you're on the right, it's a positive. And we are in the back right with the mount that I created. I came up with this very simple mount. It's just got a few holes that made up with the holes that are already in the plate on the SKGO. And you can use a square nut and an M3x10 screw to hold that inductive probe. I just made it so the mount will fit right like this, and the probe will ride in the back and not collide with anything. Also, when we are at X and Y home, this probe is still on the bed, so we can home in the corner. We don't have to use safe homing to get to the center. I just like homing in the corner better because it seems like it takes a little less time. So your mount will go on with these 3 screws. Your probe will go down just like that. I will leave a link to this in the description below. And that puts our probe offset about 59 behind the nozzle and about 17 to the right. So back to Marlin. So X will go positive 17, Y 59. And we'll set the Z offset after the fact. Minimum probe edge, I'm going to leave that at 10 just to be safe. I'm fine with probing speed and all the rest of the defaults. Let's do jump up multiple probing so we can get a really accurate map. Let's set it to 2. Moving on to motor direction. On this configuration with this board on a Core XY machine, your X and Y dir will need to be the same, and they're both true in this case. So X and Y, true, and my XZ is going to be false. That's just based on the motors and the board that you're using. Again, you can always flip the cable or adjust this setting if you'd like it to turn in the other direction. For our current Titan setup, I will also set the E dir to true. We will test all these when the configuration is done just to make sure it's all correct, but we can make a pretty good swag at it here for now. Moving on, home direction are all going to be -1. That means it homes in the minimum. My bed size is 310 by 310. My X minimum position is actually just a bit off of the bed at -5. And Y is also a bit in front of the bed at -20. That's important to set. If you're not printing in the center, you might want to adjust these. You should be able to find a setting that works that gets you right in the center of the bed when your print starts. This can also be compensated for in the slicer. And my max Z height on the SKGO is 300. They also do make a 350 version if you need one that's just a bit taller. And we'll keep going. We do have a filament runout sensor, so I'm going to remove this comment. We only have one sensor. I'm going to switch inverting to true because it's pretty much just an end-stop switch. So that should be how it operates. And we can leave the default pull up, and we don't need the pull down. We will use M600 as our default script that we run when we run out of filament. That will park the head so we can reload it. My filament sensor is actually quite a ways away from the hot end if it were to run out. I have it on the side of the machine. So I'm going to allow it to keep printing a certain distance before the run out triggers to get it out of that sensor housing. So we'll take the comment off of this filament run out distance and let's set it to 5 millimeters. That's more than enough to get it outside the housing, but we'll also have a little piece that we can grab onto when we're pulling it out of the extruder. You can adjust that based on your printer setup. And then we come to bed leveling. We are going to go with bilinear. That's what we usually do. It's the easiest to set up. And on this machine, I'm actually going to go with a 7-point grid. That's 7 by 7 for a total of 49. It's a good sized bed and it's somewhat thin aluminum. It's a 3 millimeter plate. So I want to make sure that I check it as good as I can before each print to make sure that I can use the whole bed area and it's nice and level. So let's go with that. Everything else on here should be just fine default. Z-safe homing, I'm going to leave that commented out for now, but it's going to throw an error, and we'll talk more on that in a second when we see that error. We can get around that. This means it's not going to try to home in the center because you have a probe. I want it to home over there in the corner at XY home. We'll come back to this. Additional features, I am going to enable EEPROM. That's so you can store things in EEPROM. You don't have to reflash the firmware every time you want to make a change. Only certain features can be adjusted that way. I'm going to update my filament temps. PLA 215, 60 on the bed, ABS 250, 100. Nozzle park, we'll have to take the comment off of this guy because if we want to use our filament sensor and our M600 script, you have to be able to park the nozzle. I like it to park in the front right corner, so I want it to be my X max position all the way to the right, minus 10, so 10 away from the maximum position, and my Y minimum position, positive 10. So all the way in the front, minus 10 millimeters. 20 millimeters away from your current Z point is fine with me. That's enough to get it away from the model that you're printing if it does run out. Then we get into some LCD settings. We do want SD card support. This is the SD card that is on the front on your screen. I am going to reverse the encoder direction because I like the menus to go down when I turn right and up when I turn left. That's just personally how I like them to function. There's a lot of different options in here that you can use. I do like individual access homing on the menu, so I can just home X, Y, or Z if I want. We will enable the speaker, and then we'll select which screen we have. This one has the Rip Wrap Full Graphic discount screen. That's this guy right here. We'll just remove the comment. And that is everything we need to adjust in configuration.h. Of course, we might have to come back and do a few tweaks, but we can move on to configuration_adv.h. We'll save this guy, and we'll open up the advanced file. The first setting that we come to that I would like to change is how the hot end fan works. I like it when the hot end fan doesn't come on until the hot end is at a certain temp. On the SKR boards, we can use the second extruder heater plug to achieve this. On this particular board, we're going to change this to P2_04 because that's the second set of extruder heater pins. These are located on the back of the board, your pin numbers on the SKR 1.4. as well as you can figure it out from the pins file. So the extruder fan, if you're plugged into those pins, it's not going to come on until you reach 50C, and then it'll come on full blast. Great feature, every printer should have it. Next thing we come to is home bump. I don't have a whole lot of luck using home bump when I do sensorless homing. I will be using sensorless homing today, so I'm going to set X and Y to 0. SD card connection, I'm just going to use the one on the LCD screen so I don't have to change anything here. If you'd like to use the SD card that is located on the board, you can switch this to onboard if you'd like. I am going to enable baby stepping. This allows you to adjust your layer height on the fly, and I like to use it to adjust the Z probe offset. I think that's the easiest way to set up ABL. I'm also going to enable double click for Z baby stepping because that way you can hit the knob twice and baby stepping will come up so you can adjust it. And I'm going to take the comment off baby stepping Z probe offset. That way we can use it to set our actual offset. We don't have to take the additional step and update that as well. I am also going to enable linear advance because I think it's a great feature. This is linear advance 1.5, but I'm going to set the K value by default to 0. I suggest if you're setting a K value, you should adjust it for each filament and set those settings in your slicer G-code. A lot of slicers now have independent filament G-code that you can use for each different type of filament. Then we'll come down to advanced pause. You have to have advanced pause if you have a filament sensor and you want to park the nozzle. I'm going to go with the defaults for now. I do have a direct drive extruder. If I want the unload or load actions to happen differently, you can change them in these settings. I do like to take the comment off of filament load unload G codes because that enables you to use M701 and 702. It also puts those items in the LCD menu. So you can just use your knob to load unload filament if you wish. Then we come down to the stepper section. We have our good old 2209s, so we go to Has Trinamic. The default current and steps, everything should be okay. I am using 16 times microstepping. If you run into false positive with sensorless homing, remember you can change the current while homing. Lowering the current while you home might help that issue. It is important to mention that if you're using smart drivers or just a regular driver that has a trim pot where you adjust the current, in a Core XY configuration, X and Y need to be exactly the same. If they're not, or at least really close to it, X and Y can tend to fight each other. Because essentially they're on belt paths that are somewhat playing tug of war with each other. So if your currents on those two motors aren't very similar, you might have problems. I'm just leaving these at 800 because with these drivers the current should be fairly consistent between the two, but it's just something to look out for if you're setting up Core XY. We are going to use the quiet mode Stealth Chop for all the drivers. Stealth Chop timing, I'm going to change this to 24 volts because we're running a 24 volt power supply. Motor driver status, I'm going to go ahead and uncomment this because then I can use all of these commands to check out what the driver status might be if I'm having an issue. Then we come down to sensorless homing. I'm just going to take the comment off so I can use it. 2209s and 2130s have a different range of values they use for the sensorless homing. So currently I have 2130s, they use a -64 to 63 value for some reason. The 2209s use 0 to 255. Most of the machines that I've tried to use sensorless homing on, I usually had to start somewhere around a 60 for X and Y. It's going to be different for every printer setup. But let's go ahead from 8, let's make these both 60. And we'll see how we do from there. This is also a newer feature that I kind of like, improve homing reliability. I'm going to take the comment off of that. It slows the jerk and acceleration values down so it engages whatever it hits when it does the sensorless homing a little softer. So you might get more accurate home locations that way. So you're not just ramming into the side of the printer full speed when you try to sensorless home. That's a pretty nice add-on. We'll try it in this config. And then we'll take off TMC debug so we can get as much information as possible if we have driver issues. And that's pretty much it. That's all of the different settings that I can think of that we need to adjust for this config. I'm sure there'll be things we have to tweak, but we can come back and take another stab at it. So now, let's go ahead and try to build. And I'll show you what's going to happen. Let's go to Platform IO. We will find our 1769 environment, and we'll just hit build. And we have failed. If you scroll up a bit, you see Z-Safe homing is recommended when homing with a probe. Enable it or comment out this line to continue. This is in the sanity check feature of Marlin. This is what keeps you from making silly mistakes or syntax errors, but I do 100% not want to home in the center. So let's go into sanity check. We'll go back to Explorer. We'll go into include sanitycheck.h. And let's just search for safe_homing. And we're just going to comment out this error right here. Just put 2 slashes in front of it. Now always be careful if you're making an adjustment like this. You don't want to mess up the body of code. This is a pretty safe one because the code is actually suggesting we can do this if we want. But just make sure you know what you're doing inside these files. And let's go back to Platform IO and let's hit build one more time. And now our build runs clean. Now we have some electronics work we need to do to get running on our new board before we can test our code. So let's do that portion now. This is the current board I have on the SKGO. You can see my normal wiring problems. Everything's always a mess, but I do want to change this board out. So as I'm putting the new board back on, I'll show you how everything's going to be configured. And before we dive into the electronics, let's just talk about Core XY for a second. I'm not going to dive in too deep here. That would be a really long conversation on how this whole thing works. But I do want to touch on some things as far as how the motors are configured and how that's going to be configured in the firmware. So you're in your typical Core XY config. What we would like to refer to as the X motor is going to be the one on the left, this guy over here, depending on your printer setup, of course. This guy is going to be what we call X, and this guy is what we're going to be calling Y. And that just refers to them how they're going to be addressed on the board and in the firmware. Most of the time we like to call this A, and we like to call this one B when Core XY are concerned. Because they actually have to move together to move in an X and Y pattern. And let me just show you what the motors do when we move in certain directions. So we're currently at X minimum. If we want to go towards X maximum, both of the motors, A and B, are going to turn in a clockwise direction. If we want to go back, they're going to turn together counterclockwise. Now, if we want to go from minimum Y towards maximum Y, as we move back, they are going to turn opposite of each other. Your A motor is going to turn clockwise, and your B motor is going to turn counterclockwise. And that's just reversed if we want to go in the other direction. Now, if we want to go in a 45-degree angle, say we're going from X minimum to Y maximum, you'll notice only one of the motors turned. So to go in that direction, I'll try to simulate it the best I can. you'll see the B motor doesn't turn at all. One more time on the way back. It's just the A motor to move in that direction. But what if you want to go from X max to Y max? We'll go over to that corner. Just the B motor turns to move in that direction. So that gives you just a little bit of an idea of how the motors work and how they use this core XY movement to move around. Most importantly, we know that this is the A motor, this is the B motor, this plugs into the X, this plugs into the Y. So let's get the initial stuff set up on our SKR turbo board before we install it. We got to put our drivers on. We're going to be using sensorless homing on 2209s, so we do need to add a jumper. For UART mode for those, we want to cap these guys right here for all the drivers that we're using. There's X, there's Y, there's Z, and there's E. Now Big Tree Tech does recommend that you clip the diag pin on any driver you're not using sensorless homing on. It can interfere with other pins on the board, but if you are using it for X and Y like we are, you don't need to clip them, and you won't be using them for Z and E. But as long as you're not using any of these other pins, it won't interfere. For example, if you leave the pin on Z, as long as you're not using this power detect pin, you should be fine. For E, if you leave that pin on, as long as you're not using E0 for filament runout, you should be fine. Unfortunately, we are using these pins for filament runout, so I will have to remove the diag pin off of this driver. There are other ways to getting around this, like adjusting the firmware pins, and I think I will go over that at some point, so we don't have to clip the pins because I don't like it any more than you do. But we'll load up our drivers. Remember on these guys, the potentiometer on top goes on this side. It's pretty obvious when you have the diag pins on because they will only fit in these holes. And the driver should be all set. I'm going to go ahead and install it on the printer, then we'll get it all wired up. We'll get our power hooked up here in the top. Remember on the SKR board, these are kind of flip-flopped. Power's on this side, ground is on this side, but on the bed, it's opposite. So power, ground on the bed. Don't get that flip-flop, that might be a problem for you. The power's on and we'll just kind of work our way around. This one does have a fan on it to cool the drivers. You probably don't need that with 2209s, but more cooling never hurts. I just put this in the constant plug right here. Our hot end heater cartridge wires will go in these slots right here, HE0. Remember, your heater cartridge is not polarized. Negative or positive does not matter. Our part cooling fan will go in fan 0, which is this one right here. Then our hot end fan wires will go in HE1. That's for a second heater for a second extruder, but we're going to use it to control our hot end fan. Those will be polarized, so make sure you have them on the right side. This side is going to be positive, this side negative. Moving on, we have our extruder motor wire right here. That goes down here. And we have our hot end thermistor wire, which goes right over here on HT0. We will install our bed wires. This printer has an SSR. It's an AC bed, but we control the SSR with the board. You do need to make sure you have the right ones on the right lugs. They will go in the normal bed plug right here. We'll put the positive on this side and the negative on this side, just like that. We're going to use the EN0 plug. If you're used to using that as a X max in-stop, it's in the same location. We're going to use that right here. This is just our filament sensor switch. Our heat bed thermistor goes right down here in the corner. We have our LCD screen connections, EXP1, EXP2. Then we can go ahead and hook up our X, Y, and Z motors. I'm using this ribbon cable. It just kind of groups them up, makes it a little easier to manage. But remember your X motor, we're going to call it your A motor. That's the one on the left side of the printer from the front in a standard Core XY design. That goes on the X plug right there. Then your B motor or your Y motor goes on the Y plug right there. And Z just goes to Z. Just like that. And our added inductor probe over here, we're going to throw on our Z-min pins right there. And we should be all wired up, ready to go. Back to VScode. I have cabled it up USB to the computer. I have powered it on. Let's see if we can upload. We are in the LPC 1769 environment. Let's just hit upload. And we have hit an auto detect error on that COM port. It happens sometimes. I'm not exactly sure the configuration on that board, so you have two options. You can hard set an upload port in your INI file, or we can just pull the SD card and load it from our computer, which is what I'm going to do. I plugged in my SD card. You can also just upload to that device. You don't have to go copy that firmware bin file unless you just want to. If you just hit upload now, it should find that SD card as your upload port. See, it found upload disk F, no problem. So now we succeeded. I can remove that card and load it on the printer. And before I power on, I'm going to get a loose adjustment for the Z probe. You've seen me do this dozens of times. I'm just going to loosen up our mount. I'm going to pull the belt so that the nozzle touches the bed. Slide a zip strip under the probe, push it down, and then tighten up my mount. You don't want the nozzle to collide with the bed. Just be careful. You might need to adjust it a little bit up or down depending on your configuration, but we'll start there. Also, depending on how your Z end stop switch was set up, I've got mine on this adjustable screw mount. I'm just going to back the screw off so I don't collide with it any longer. The bed should be just a bit higher. I just don't want to engage this screw on that switch any longer because we're going to be using the probe. Now let's power on and run some tests. We've got the Marlin splash screen. That's a good sign. Remember, when you first boot up, it's always a good idea to reset EEPROM. M502 to load the stored settings, M500 to save. And you can take a look. Make sure all the settings in here look like what you expect. The ones we just configured, they look good to me. Let's just do our usual tests from Pronterface. We'll move around a bit. We'll try X positive. Looking good there. How about Y positive? Looks good there too. How about Z positive? We're all set there. And let's just try to home X. Remember, we haven't adjusted the sensorless homing. It's set to 60 right now, but let's see if that's high enough of a sensitivity to stop it. So let's just do X. And it stopped. It crunched just a little bit, so maybe a little bit more sensitive, but not bad. So now let's try Y. Home Y. And we stopped. So I'm pretty satisfied with that. Now we want to be careful when we're adding a probe to any printer and we're trying to home. We might not want to do the home all at once. We probably just want to bring it up slow and check it with an M119. So let's do that. First we'll do an M119. Our Z-min is currently triggered. So that's the opposite of the logic that we want. So I'm just going to hold some pliers underneath it. It's triggered now. I can see it on the LED. We'll hit it again, and now it's open. So we need to flip-flop that logic. So back into VScode. That's where your end stop inverting comes in. We'll go to configuration.h. We'll just search for end stop, and here's your end stop inverting. So on Z, we'll just change that to true. And same for Z-min probe end stop. They have to be the same. Change it to true. No issue. We'll re-upload and try again. Our upload is complete. Let's power off, power back on. And we'll go back to testing. We'll connect back up. Let's run our M119 again. Now we're open. And if we test again with a pair of pliers, M119, we are triggered. So the probe logic is working correctly. Our filament sensor is also open. We can stick some filament in there and make sure it's going to trigger correctly. It is now triggered, M119, it's triggered. So its logic is correct as well. Now, let's just bring the bed up slowly until I see the light on the probe. You can use M119 as well, but I do have a light on top of the probe, so I'm just going to bring it up. It has triggered. Now I'm going to move the nozzle back just a little bit to make sure it's not going to collide with the bed. And there's plenty of clearance. The probe has actually already triggered, and we're way off the bed. So that's a good sign, and the probe is still above the nozzle. So to lower your offset a bit, you can actually raise that probe up, or just adjust the offset accordingly. But I think we're good here. Let's go ahead and home all. And we have homed successfully. Let's do our G29. This will run our auto bed leveling sequence. And our probing failed because the probe actually ran outside of the bed area. And that's because the spring steel sheet that I'm using isn't actually as big as the bed area we put in. There's a couple of ways you can fix this. The easiest way by far is to just adjust your minimum probe edge. We'll go back down to the probing section. And I'm just going to bring this up a bit because remember, this is around the whole edge of the bed. So it's actually going to squeeze the grid together a bit. So let's take it from 10 to 13. We'll go ahead and upload again. You can see this time on our 7th probe, we're inside the bed sheet. And our bed level is complete. I'm going to go ahead and heat up and make sure the fans are working as expected. And the fan actually didn't kick on. I had the wires flipped. So on the hot end fan where I plugged it into HE1, it's different from an SKR3 to a 4. I was actually looking at a 3 when I was wiring the 4. So be careful of that. I'll leave you a note. And while we're heated up, let's go ahead and do a test extrude. Make sure our extruder gear is turning in the right direction. And it is. And we'll M106, make sure the part fan's working. The part fan is working. And our map is kind of all over the place. I really don't like the adjustment knobs that came on this printer, but I think I have a fix for that. So my idea is I have these M3 female standoffs. I'm just going to put those on the existing extrusion and use these for the bed to set on. That way it'll be stationary. We now have ABL, so we shouldn't need to adjust it unless we adjust it with baby stepping. And it should hopefully make it just a little bit more consistent. The current manual setup that we have now is kind of a tripod. There's 3 of these wing nuts and screws with springs where you try to adjust it and get it level. It's never worked out for me very well. So the idea going forward, there are holes, 6 holes all around this bed, but there's 1 in each corner and 1 hole on the corner of the extrusion to line up with the bed. So I'm just going to set the standoff down inside the extrusion and then use an M3 screw from the bottom and a flat from the top. So hopefully that'll just keep it stationary in place and solve some of our problems. I've got all 4 of the standoffs on. The install went pretty well. It looks pretty good. Now let's go ahead and run our G29 again and see if we can help out our level map any. And here's my new map. I did make a fairly large hardware change, and it's not completely consistent, but at least I don't have a lot of pluses mixed in with my minuses. It looks like the front row is a little low, back row's a little high. There are a few mixed signals in the middle there, but nothing that ABL can't handle. I might go back and adjust the hardware a bit to try to get it a little better, but for now, I think we can continue on. So I've got the filament loaded. I'm just going to start a print now, and I'm going to set the probe offset with baby stepping on the LCD. So when the print starts, I did add G29 to the start G code. We'll have to home, wait for G29 to run, then we can set that offset. So we're off and printing, and we are way too far away from the bed. Our current Z offset is set to 0, so we're going to have to dial that down. But with baby stepping, I can just double click the LCD, and I can start rolling that down until I think it looks good. And I ended up with an offset of -1.663. That gives me a pretty good first layer in my opinion. So we can just click that, and you can either save it here in EEPROM, just click, go to configuration, scroll all the way to the bottom, and hit store settings. If you head back to Printerface, M503, your M851 right here now says Z -1.66. So we should be all set up, ready to go. And now our Marlin Core XY config is complete. And we even did a few upgrades to my SKGO that in my opinion will make it just a little bit more user-friendly. There will be all the information linked in the description below, including the parts that I created and this config. Hopefully you found this helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.